Okay, good morning. We are from group 9. We'll answer the question for the assignment dynamic part 2, which is question 2 and question 9. Question 2 will be from chapter 16, planar kinematic of rigid body of velocity, and for the question 9 is from chapter 18, planar kinematic of rigid body, work and energy. So we start with question 2. Bar AB has an angular velocity omega AB 6 radian per second at the instant shown in figure 2. This one is figure 2. So the omega AB is this one, has put in the figure. When you see the figure and the omega AB, we know that the angle of the bar go to the left. That's mean for the C, this is A, B, C. For the C will go to the left and B will go to the left also, but in a straight line perpendicular with the line with the bar AB. So we can say that this one AB perpendicular straight, this one is BB, and this one is, we can say as RAB, and for this one we'll go straight to the left, VC, and this one, this line is the BC. Okay, we get to understand the figure, how that it rotate. This one omega AB rotate to the left, so this means VB will go to the top left, and the for the C, board C will go straight to the left. Okay, so we proceed with the question. They ask about the A, sketch the location of instantaneous center of zero velocity of bar BD. That's mean BC, D this mean around here. Sketch the location of instantaneous mean the IC. They want the IC. What is the IC? So the IC is first I will draw the FBD. I have drawn the FBD diagram. So I will use my blue color pen to make the line of the instantaneous. We know that the IC is perpendicular with the B, so that means this one straight around here, and for the VC perpendicular to the for the line here perpendicular with the VC, so that means straight top or bottom. So we choose top because it will become triangle. So we know that this one is 90 minus 10 is 80, so this one is 80 degree. And for this one so if the zigzag B, z of A to here 45, that means this one also 45, and this one is become 55. So this point here and here, this point is the IC. This point is for the D. What they want is bar BD. Bar BD is BD C. So this one is the point IC, instantaneous center of zero velocity. So we have answered for the question A, and then we proceed with the question B. Compute the velocity of the slider block C at this instant. So what they want is the block C moving, velocity of block C, so that means the VC. So the VC is this one. Sin, we don't know what is the VB, what is the RAB, RBC. We first velocity equation. So we want to get the VC, so that means VC is the main body, and then VB plus with omega BC time with RBC. Okay, we want to get the VB. We want to get the VC. We don't know the VB. VBC and RBC we can find from here. So first we need to complete the VB. So VB magnitude, we need to complete the magnitude of VB. Magnitude VB. So this means from from A to B, we know that this one is the fixed. This one is fixed. So we just write the equation VB equal to VA plus omega AB time RAB. We know that VA is fixed, so VA is 0. So we just write again the equation VB time RAB. So we know we get the from here, from the figure, we know that the omega AB is 6 hidden. Omega is angular velocity, and the R is the position vector from A to B. So this one is VB, omega AB is 6 time with position vector from A to B is 0.2. So VB equal to 1.2 meter per second. Since VB have angle, so we need to include the angle inside the VB. So this means we use the VB I just write the answer 1.2 cos 45 I minus 1.2 sin 45 G. How did I get this? It's from the this axis. This is x axis, this is y axis. X for I, y for j. So from here we see this VB at here. So the angle here 45. So we know that VB so we know that VB 1.2 cos 45. Sorry, this is negative 45 and 1.2 positive. So we get negative 0.8585, 0.8485 I, positive 0.8485 G. So we have complete for the VB. This one is the complete one. Then we proceed with, we just input into here. So the equation from here, we will get VC equal to VB plus omega BC times RBC. So we just write VC we know that it at x-axis. This means this one. This is x, this is y. We see it at x-axis, the I1. So the ijk, that one for the ijk. So it to the left, so negative. Equal to we just write from here negative 0.8485 I plus 0.8485 J plus with omega BC. Omega BC is this one, BC omega. So that means sin omega is in the z axis. That means it k, omega BC k time with RBC. RBC is 0.5. So we use this xy, the BC, so C here, B here, so the 10 is here. So that means for the axis 0.5 cos negative cos 10, negative cos 10 degree. This is for the I, and for the y positive 10, positive 0.5 sine 10 degrees. So close bracket, close for this one, because this one we need to multiply with this. So okay, you know about the multiplication of this one is J, ijk. The one is this one, I. This is the easy way to understand, to remember the flow. Ijk. So I to J is positive, J to K is positive, K to I is positive, and for the I to K is negative, K to J is negative, J to I is negative. So from here you see this is one is omega b c k. K here will multiply with I, so K multiply with I, so we will get positive J. So wait, I just write again the equation here, the answer here. Negative 0.8485 I plus 0.8485 J plus. So this one is we know that 0.5 cos 10 is 0.4924. Omega BC, K to I become positive J, so J. Sign this one is a negative, I forget about this, so it will become negative, plus with omega BCK 0.5 sin 10. 0.5 sin 10 is 0.0868 sine 10 is 0.0868 for the omega BC, and then K time with J. K time with J, sine it anti-clockwise, it become negative. So that means become negative I. K J become I. So this one negative. So I will just write again for you to see. BC I negative. negative 0.8485 I positive 0.8485 G plus 3 negative 0.4924 omega BC G negative 0.0868 omega BC I. So from here we can equate equating the I and J. J. We will equating it. This one negative VC equal to negative 0.8485 minus with the I here 0.0868 omega BC and the J 0 because there is no J in the left equal, so in the right equal 0.8485 minus 0.4924 omega BC, and then we use the simultaneous equation. We get the omega BC from here 1.723 radian per second, and VC velocity of C we get the 0.998 meter per second. I think that's all for now. After this we'll proceed with the question 9.
Hello everybody. Okay, next we are going to discuss or solve another dynamic question. Right, so this is the figure. As we see, this figure is consists of two wheels which are attached to one another and turn at the same rate. So the block A has a mass of 30 kg and is initially at rest. So this is the constant force 3 kN is applied to the rope wrapped around the inner hub of the pulley. Okay, now we are going to draw the free body diagram from the figure. Okay, this is a constant force 3 kN, and then this is block A 30 kg. So this is the rotation of omega, and then the radius for the big is 0.2 meter, and then for the small radius is 0.075 meter. From the question, as we know that the mass of pulley is 10 kg. So 10 kg times with 9.81, so we get 98.1. Okay, so for the block A, we times with 9.81, so this for A 294.3 Newton.
From the FBD, we must know how to determine the angular velocity of the pulley, as the question wants. First of all, we must know the equation to calculate the angular velocity. For the angular velocity one, we know that it start from the rest, so we cut to the zero. Then we assume that the direction of omega is clockwise. Next, for the next step, we must calculate for the moment. This. Then we put the limit from 0 until 5. Limit 5. For the formula moment, we know that moment equal to initial alpha. Then we write what we want calculate. As for example, block A multiple RA plus F multiple RB. Because we assume the omega from clockwise, we know that block A will be negative value because it's downwards. (254.3 Newton multiple 0.2 meter plus 3000 Newton multiple 0.075 meter. So we got for the moment is 830.7 Newton meter. When we got the value for the momentum, we must calculate the value for the angular momentum. Angular momentum equal to initial generation times angular omega plus mass times velocity times radius. As we know, the initial generation for the sphere is mass times kinetic square root. For the V naught equal to omega times radius. Then we include this formula into this equation. Then after we got this equation, we include the value that we got from the FBD. We got the formula for angular momentum equal to 1.3 omega. Then after we got the value, after we got the 2 value, we include this value into the equation. The value that we got for the momentum is 830.7 equal to so the angular velocity is 639 radians per second. That's all. For the next question, we will solve the speed of the block. For the formula, speed is V equal omega times radius. The omega that we got from earlier is 639 radius per second times 0.2 meter. That's all. Thank you.